first time I gave a lecture about Angular. It was at Google, and nobody knew what I was talking about. And also, when I started doing Angular, I went to Adam and Boris, and I told them I'm doing Angular, and they told me, "What the fuck is this shit?" Oh, I don't know if I can say that, but but they told me to use jQuery mobile and like Backbone or something. So I've been doing this for like very long time. I work currently on the Apollo team and the Meteor development group company. And I also work a lot with the Angular team themselves. I just came back from GraphQL Summit giving a talk with Jeff Cross from the Angular team about how to fetch data in an Angular apps. So how many of you has heard about GraphQL? Have heard about GraphQL? Oh, nice. That's great. So that's usually more than when I started talking about GraphQL. So that's really good. So I'm going to talk about GraphQL. I'm going to explain basically how it started, about the specifications themselves, but then why, as Angular developers, like we should really care about those things, and why stuff that we do today to fetch data or stuff that you and I do today is probably wrong. So GraphQL got like, it's becoming really huge. Like I just came from this summit. It was a huge summit. It's now a kind of a movement. Like those are just some of the companies that actually use GraphQL in production today. So maybe like if some of you are thinking about it's a new thing or something like that, like all those companies here are using it. Those are just parts of them. A lot of them are clients of ours. But the thing is that it didn't start now. It's not like it started. And by the way, yeah, there's GitHub. I don't know if you heard, but GitHub like changed their public APIs now to GraphQL. Their internal APIs are all GraphQL already. So everyone is moving to GraphQL instead of REST, and there's a reason. But also, that's the initial reason of why actually we have GraphQL. Facebook, back in 2011, all their mobile apps were written in HTML5 with a very simple APIs. And they realized that all of their revenues is going to come from mobile. And there was, back at the time, there was a big threat from Google with Google+. Now everyone is like laughing about it. But basically, but this is because of a lot of the thanks to GraphQL, because Facebook had to change their old existing backends into a new front end, new apps, and give them modern APIs. And they need to do it fast. They didn't have time to rewrite their old backend. So if some of you are working in large companies, like you should take a good look at this example of how Facebook did that. And today, Facebook's, I think like 87% of the revenue comes from mobile. So it was probably one of the most successful change, like internal change of a company outside. So GraphQL exists for a very long time, and it didn't start from JavaScript. It was actually came from this app. It was actually started by the iOS app, native app from Facebook. So why Facebook did GraphQL? I mean, there's REST, and there's like RAML, and there's Swagger, and there's like tons of like other solutions out there. So let's talk about REST, for example. One thing is that let's say we want to render like a list of repos or a list of something. What we currently do with REST is that, and then the information of those repos, like GitHub repos. So first of all, we need to fetch the list. What we usually do in REST is we need to fetch the list of the repos. And then once we get the list of the repos, we need to fetch the information. And then for each, let's say we want the contributors. And then for each of the contributors, we want the name and the age and other things. Every time we do that, and it's all in one single renderer of our applications, like one single root of our applications, we go and send multiple requests to the server. And this is expensive, and also we don't get exactly the data that we need, because we get contributors, but the server decides for us what we're going to get there. And then, like some of you who wrote REST endpoints would say, oh, but I can just create this like an REST API point that has exactly what you want. And that's nice, but what happens then is that if I want all the information on the repos, I get a lot of information that probably I don't need. And also, I'm being decoupled from the server now, and I'm sure a lot of you have like came into this like into this problem where you want to change something in the front end, and then you need a new API from the back end, and the back end people it takes time for them to do that, and then you end up with like 5,000 endpoints, and it's a mess to organize that. So there's always a tension between having a generic REST endpoint that the server people like, than having the like fine-grained REST endpoints and maintaining them that the clients people want. And this thing would never be solved unless, and there's one another thing, like, and I'm sure all of us are front-end developers and we probably get it a lot. We're going into an integration with the back-end people, and I'm not dissing back-end people here, like I'm a back-end people as well, but the thing is that we're going into integration, we agreed on like / a person, we'll get the person details, but we don't know what are the person details. Like one day we did an integration, we got the name and the age. Then someone on the server decided to remove the age. Now he's sending like an age as a different field, and it broke our application. And this happens a lot, all the time. And actually, if we're thinking about most companies, this takes the most time, like figuring out what's the APIs and keep maintaining it over time. And Facebook, luckily, got the same problem, so we're not alone there. So Facebook invented GraphQL, and GraphQL basically lets the client specify the needs. The client will say, I want this information, and it will get exactly that information from the schema that the server exposes. And I'll show you how it works. So basically, we have a schema over here, and the schema just said, I'm a server, this is what I can give you. And it's a typed schema, and it's statically analyzed, and I'll talk soon about why is it good and why is it important. But then the server, the client just says, give me the title of the post, and that's it. And then you'll get a response that looks exactly the same. So you don't overfetch data, you get exactly what you need, and if the client now wants to fetch more data, like the votes, you don't need to talk to the server people. You just need to do it. So like I said, you request exactly what you want, and it's super simple. Like this is how it looks. This is the query, and this is what you get in response. Also, something very important is that it doesn't matter this query, it doesn't matter how nested it is, I will get it all or in one single response. So now every time I'm rendering a new page, I will get just single response, and that's it. I don't need to handle a lot of request response, and more important than that, I don't need to do very expensive and complicated joins on the client, because I have great tools on the server that will give me exactly what I need. And most Angular applications do that. Most Angular applications, we call a lot of REST endpoints from the server and then start joining and merging things, and it costs a lot of energy and time. And another reason that it's really important that the API is actually a schema is that it can statically analyze. So first, it means that when I'm developing something, works? Yeah. When I'm developing something, and like this is React, but it doesn't matter, it works also on Angular or any other JavaScript framework. When I'm running my APIs, I have exactly what I get with TypeScript. I have auto-completion, and I have error checking and documentation. And nobody had to write it. It's all automatic, it's all from the protocol itself. So think about it. Everyone here is talking about TypeScript and how great it is. But TypeScript is validating your own code. But you're not validating your server people code at all. So and I would start from the API, then go to your own code. So this is amazing. This is like the benefits that TypeScript give you is like really small compared to those things. I'll just show, well, I have a lot to cover, so I'll try not to do too much code. Oh, I don't know what that's it. not to do too much code, but like I showed before, this is really simple. So this is, by the way, just a site, GraphQL.org. It's a great site. And I can just, let's say I have a hero and a name, and the hero has friends. So first of all, this editor, you can get it the same inside your IDE, whatever IDE you're using, and you have auto-completion, but also error checking. Like if I write here like friends and it will be like wrong or something, I have error checking. But I want just to have the person's friends. And then for each of these friends, I want the name. And you'll see I get in one single response the name and exactly in the structure that I want as the client, not in the structure that the server people decided. And then the friends also have friends. So let's take their name. And let's see when they appear in. And now you see it's even one level nested more, and I still get one single request, one single response, no joins. And let's go down even deeper, and let's take the friends connection, and let's take like how many friends do I have, and then also get the friends and their names. And you see that I have in the internal like very, very deep net, and I can go forever today, so I won't do it so much. But the thing is that no matter how nested you are, no matter how many components you render, you'll get exactly the information in one single response like you want it as a client-side developer. There's a great example. I'll skip it for now. Where's my slides? OK, so yeah, like if you want to read about the spec, I think like a few months ago, GraphQL.org was a really shitty website, but now like we're reading it like from scratch, and it's really cool, and you can live code inside the website. It's a really cool website. Check it out. A thing that is important to understand about GraphQL, and this is why the Facebook story is so important, is that Facebook didn't have time to rewrite their backends. And this is a mistake a lot of people are doing. Like we're working in a company or a large company, or we're coming as a consultant or whatever, and then we're writing our Angular apps, and we're so excited. We're writing everything so fast, and we finished our Angular apps, but the backend is old, it's not giving us what we need, it's a mess. And then we're waiting for the server developers, waiting and waiting and waiting. The good thing about GraphQL is that we don't need to wait for them. It's a middleware. We put it on top of the existing servers. We don't have time to rewrite our servers, and we don't want to rewrite our servers. So GraphQL is actually like a layer on top of our existing servers. We can just place it there and get all the benefits, and that's what Facebook did. So, but we're Angular developers, so this was the protocol, and the protocol gives us a lot of advantages. Let's think a little bit about the client and the new way we write clients in Angular 2 today, and how do we fetch data. So we can just do, like, if we want to just start writing GraphQL apps, we can just write like we used to write today. We can set a post request or like a get request, just specify the query and get the results. And that's fine, but today we're doing stuff a little bit differently. Angular apps are built, everyone is talking about here about components. Like components is this new thing, everyone is writing component, that's fun. And the cool thing about components is that like you can just reuse them, right? You can move them from place to place, you can change one component, it won't change the other components. And that's cool, the idea is really nice. But when you actually start to write with this thing, and you're actually trying to get server code, then everything goes to mess. So let's see about like how do we do it today. So first of all, let's say we have a GitHub issue and we want to render the GitHub issue with Angular. So the most simple thing is just let's send a REST request. So this is the GitHub issue component, like a pretty easy, like simple component. But let's say we get the HTTP, the Angular HTTP service in. It has observables, and we're very happy with ourselves. And we just, inside the component, we do an HTTP GET and get the information from the endpoint. That's cool. And then we render it. And we have like, we render it with the async function because it's an observable. That's fine, but what are the problems with that? Well, first, the thing is that we render multiple components, right? And they don't know about each other. So we're sending multiple requests to the server. The components don't talk to themselves, between themselves. So now we're fetching all the information. We're fetching redundant data. Like we can fetch the same data from this component and the other component. And now, and there's too many requests and the performance is horrible. So then we're being smart, we're being Angular smart. And we say, yeah, let's use a service, right? This is how you actually call HTTP requests, right? We're using like services. Services are great. It's a good idea because Igor said that or someone. But then there's a problem. Let's demonstrate it first. So I'm injecting a service. It's like a GitHub service. It holds all the endpoints for using GitHub. And yeah, and I'm getting the issue and render the issue. But the problem here is, again, what happens here is that we're moving all the endpoints to the service. So we have one single place that holds all the data. If I'm moving now the component to a different place or the component needs to change, I need to change stuff outside of the component. I need to change the service. But maybe there's other components that also use the service. So maybe I'm destroying the other components. So service is a very nice idea, but when you get to a component-based app, which is what we write today, it doesn't make sense. And then we have the third approach, which is, okay, so let's put everything in a parent component. We use smart and dumb components, and the components will expose their API up, and like that. So the component will say, I want the issue title, or if now the component wants a new thing, I want the issue created date or something. But here there's also a problem, because what happens here is that every component they use, our internal component that changed, now if the API of the internal component change, we need to change all the components on top of it. So where are our components? They're not components anymore. We lose everything. And most of our applications here use a server. Like most of the Angular apps that are written are using a server, so we can't ignore this problem. So what if we could actually write components that hold their data information, and if they're changing, it won't change anything else? The good thing is that GraphQL was built to that, because GraphQL was also used by Facebook with React, and React is also a component-based framework, and they tackled the same problem. So what happens with GraphQL is, because those queries are very simple and they're statically analyzed, I can put the queries next to the component. And then I'll have a central client that will analyze, when I render something, will analyze all the queries and will bash them together into one single request. And then when I get the response back, we'll send the data automatically. And when I change some field inside the component, nothing else will change. So let's look at an example. So this is the same component, and this component now needs an ID and a title. So we just write an ID and the title on top of the component. We can put it in a decorator if we want, or whatever we want to use. And now, so that's the only thing. But now I want to also render the created at. So I just change that component, and that's it. No service, no parent component, nothing. One file, and we didn't even need to change the server. So this is very powerful. This is the modern way of writing apps. Now, on top of that, the client gives us also performance benefits. I won't have time to touch on all of those performance benefits, but one thing that I talked before is that I'm going to get, doesn't matter how many components I'm rendering, I'll get with the client, with the GraphQL client, I will get all of those requirements in the render in one single request and one single response. And then when I'll move to a different route, I'll render a few other components. Again, one single request, one single response. And more than that, this client can hold the store, and we use Redux store, but it doesn't matter. It's just an implementation detail that holds all the information. So if actually now we have the same components that use the same data, then if on the second request we got a new data and it was updated, it will update all of the information in all the other rendered components. So we get data consistency across of all of our components. So yeah, and I've talked a little bit about typed API and how it actually helps us when we actually write our code with auto-completion and things like that. Now, I won't touch a lot on the server because we're not writing servers here, but just important points that are important to understand. Like, first thing is that GraphQL is not a storage language or not a database. What do I mean by that? It means that GraphQL sits on top, it's an API, it's like REST. It sits on top of all of your data services. So it doesn't matter if you have one server written in Node, and then you have another microservice written in .NET, and then you have another database that is written on Postgres and another database in whatever, and you call a third-party API. For the client, all of those are formed into the schema that I showed before, and this schema can be used by any clients, and each client will specify its own needs. So, and this is just an example. The way it's happening is that each field in the schema is actually a function. So let's say if I'm querying, and this is, by the way, a complete GraphQL server, if you would just want to play with it. You don't have to. There's like a lot of services right now that are like Firebase, but with GraphQL. If you do, like the idea here is that, let's say if I'm querying a person, a name and an age, the name can come from a Mongo database, and the age can come from a third-party API. And I will get it all in one single request to the client. So it gives us, like, we also, as the server developers, we see that as a microservice orchestration level. We can actually, like, build like a GraphQL layer on top of it, and then start breaking our, let's say, our monolithic server into a lot of microservices. And again, the client, us as client developers, it will be like, we won't see that. It will just work. And so we have a saying that GraphQL is for any backend, any client, and any language. So these are just like an example of all the libraries written in Ruby, .NET, Elixir, Java, React, Vue.js, whatever you want to use, you can use it with GraphQL because, again, it's a protocol. It's an open source protocol. It's not a language. And then just a lot of like questions that I get from the server developers are, wait, like if the client can query whatever it wants, isn't it like not efficient, or like REST is more efficient maybe? So no, actually it's much more efficient because you can start by just writing the most simplistic implementation. And then you can, because you can very easily analyze the information that the client actually needs. Like today we're calling a product API, but we don't know what the client really needs. But today with GraphQL, you say the client needs a name and an age, so we can optimize specifically the name and the age. And usually, like, this is a tool that I'm very shamefully, like, we sell this thing. This is how we make money. This is a tool that tells you by the field how long it takes and which fields are running synchronously or asynchronously. And usually, when we get to a lot of companies, we get into this product, and after 1 hour, from being like a server that is total mess, we get into a very optimized server because we don't optimize ahead of time, like REST endpoints, but we optimize for the specific data that actually like takes a lot of time. So like I said, we all use everyone is talking about TypeScript, and it's great, but you need to use types for your server and client APIs, because otherwise, most of you build a great Angular app, but most of the time will be wasted with integrations. And the great thing about it is that if we think about Facebook is not a finished product. Like Facebook looks the same probably like for the last few years, but every day they open up like 50 new features and then shuts down like 49 of them because they didn't work. And this is how modern products are written right now. The front end, it keeps changing all the time by the product developers. And in Facebook, the real users of GraphQL are the product developers. They are adding features, removing features, and they're not talking to the backends at all. And on the other hand, if you're thinking about the backend people, they just need to expose the schema. They just need to expose what they want, and then GraphQL will do the work of supplying the crazy front-end developers what they need. So in summary, I'll have you to take as front-end developers like through 3 important points. One is that we're reading now component-based apps, and Angular 2 is like super fast. Like, I don't know if there was a talk here, but the rendering performance of Angular now is crazy. Like, there hasn't been anything like even close to it. And for a long time, we've been reading applications usually separated from the client and the server. So the thing is that we need an API that suits that new type of app. We need a component-based API, where the API and the requirement sits inside the component. We need we can't afford to actually go multiple round trips when you render our page, because we need one request, one response. By the way, we can get multiple responses, because GraphQL also supports like real-time data. So if you are over WebSockets or not WebSockets, so I won't talk about it today, but there's subscriptions API, like there's PubSub API, which you can use also for real-time, which REST obviously doesn't support. And one thing that emerged is that GraphQL first approach. GraphQL first approach means that you start from writing your schema, you start a new project, you start from writing your schema, and then the server developers and the client developers work completely separately, and when they come back together to work on something, it actually works. Unlike other technologies that had that promise, like, I don't know if some of you work with web services and all kinds of stuff like that. So because of the client-side developer tools. So to get more information about it, like just check out Apollo Client. This is the client-side library that we use. It's actually most of the code is shared between Angular 2 apps, React apps, and also Angular 1 apps. If you want to write with Angular 1 and a component-based API and start doing all the things that you hear that are good in Angular 2, you can do the same in Angular 1. So there's examples for everything, also for iOS and Android, like native iOS and Android. Yeah, and I think I have even a little bit time for questions. So you can, first of all, you can check out my GitHub. It's github.com/urigol. My email is there, so you can always contact me. And for more information, you can go here. Thank you. Yes. Calculated fields on the server side. What? Can you talk? Great, so it is in the schema, but because for each field it's not related to the database, it's actually an arbitrary function. So you can run whatever you want. You can calculate I don't know, you can calculate a value and return the value. You can call a REST endpoint and return the REST endpoint. You can call a database. You can do whatever you want. It's like I showed before on the slides with the server, it's just a function. So you have a function, whether in JavaScript or .NET or whatever you want, and you can run whatever you want with it. You first agree on how you expose it with the client. This is the schema. But then you can solve the schema in any way you want. So any data is OK. There's the question that people ask is, does GraphQL work with X? It works with, the answer is always yes, because it's a function. You can put a GraphQL on top of REST. You can move GraphQL on anything you want. So there's no excuses to not use that. Another question? Yeah. Yes, there's a few projects that do that. Usually, usually what happens, there's a lot of like best practices around it. Like you can actually generate the schema again and again and again, depends on your runtime. And then, because one thing that is important is that the schema can declarate itself. So the tools, the cool tools that I showed here is that the schema itself, you can query the schema for how it looks. So it's important to, there's many like mechanisms behind it that you need to generate it again, but there's a lot of like tools and best practices on how to like regenerate or change the schema over like on the fly. Yes, this crazy person there. Oh, that's a great question. What about updates? So yeah, it's not just a query language, because you can also mutate. You can run a mutation, like and this is the equivalent for post request. And the amazing thing about it is that you actually like write the name of the mutation. Yeah, I won't show you it now, but you run the function, but then you can also attach a query to it, which means today we run a post request, and sometimes we get from the server 1, or we get from the server true or false, and we're like, what does that mean? But with GraphQL, we send a mutation, and then we declare in query, in GraphQL query, the information that we want to get back. So we can declare, I just like submitted a new comment, please send me the total count of the new total count and the new comment. So I can decide as the client-side developer, how do I want the response for the mutation or the post request to look? So that's a great question. And that's my time. Thank you.